can remember what we have seen in the last class, we have seen the basics of bottom-up and top-down approach. That is, starting from the start symbol, we are getting to the our strings, final strings, which needs to be passed. This is in the top-down approach, and the bottom-up approach, the strings is given. From that, we will try to reach our start symbol. This is this way. Both the top-down and bottom-up approaches works. We have seen in the last class. Now, let us see. If you want to pass these things, that is x minus y star x plus y, and x minus y is in bracket. Let us see what should be the production rules for these particular sentences and to grammars. First, you just see the parse tree for these things. Starting from your start symbol, we have reached in this way, and we have finally reached to this thing. That is our final string is x minus y is in bracket star x into plus y. This is the things as we have seen, and this is basically parse tree or the abstract syntax tree, which you have seen in the earlier class also. Now, what is ambiguity? Ambiguity, basically, a grammar is ambiguous with an expression defined by this grammar has more than one structurally defined parse tree. That is, has more than one structurally defined parse tree. See, suppose this is our production rules for the arithmetic expression. That means E produces E plus E, or E produces E, E star E, or E produces N. N denotes any unsigned integers. Now, if you want to parse this expression, that means if you want to draw the parse tree for this sentence, 6 into 17 plus 23, you just see there may be two derivations of this tree. Just see. This may be one, this may be another one. These are the two defined parse tree. Here we have start from this production rules. In the left side of the tree, we have start from the production rule E produces E star E, and in the right side we have start from the production rules E produces E plus E, and that is why we are getting two defined of parse tree. That is, this grammar is a ambiguous grammar. This grammar is a particularly ambiguous grammar. What is the problem we will face in case of ambiguous grammar? Can you tell me?
So different output will be there.
Yes, sir.
Yeah, defined. You
Multiply
will
or
get
plus
defined output.
the-
Yeah, yeah. You just see. Sometimes you get this output, sometimes you get this output, because these trees represent two defined ways of computing the values of the expression. That is the things. 6 star 7 plus 23, and this is 6 star 17, 6 star 17 plus 23. That is 17 and 23 will be evaluated first because it is in the bracket, and then star as per these production rules. You just see. And here actually you will get 6 into 17 plus 23. That means two values, and that is why you are getting two outputs. Then how to overcome this ambiguity? That means we have to modify our production rules. How to do these things? Here we are denoting in such a way that E produces T, or E produces E plus T, that is expression and terms, and this is the integers. Now T produces N, or T produces T star N. If you can do these things, instead of that grammar, E produces E plus E, or E produces E star E, or E produces N, the same grammar has been modified with the help of some new terminology, some non-terminology we have introduced here, and that is why you can avoid the ambiguity of this grammar. And in that case, grammar will produce only one parse tree. Is it clear?
Yes, sir.
Now you just see, this is an example of a long phrase. That is the dog, or the dog that chased the cat, or dog that chased the cat, that caught the mouse, dog that chased the cat, that caught the mouse and chewed the shoe, like these things in this way. You just see here, what should be the grammar of the long phrases? Just see. This is our, as per the simple English statements. This long phrase produce the noun, or the noun that verb, or long phrase may produce the long phrase also. A noun produces cat or chair or dog or fruit or mouse or shoe, like these things. And verb produces caught or taste or chewed or squashed or stained, like these things. In this way, we may overcome, can find out these long phrases. That means we can build the long sentences in English, and this is your production rules. And you just see clause. That is the grammar, the dog that chased the cat, that caught the mouse, that chewed the shoes, like these things. That is, you just see grammar of clauses. How can I do these things? It's a long phrase. I've seen clause may produce long phrase, and clause basically what is that? Long phrase, verb, long phrase. In this way, that means clause produces long phrase, verb, long phrase. Now you are getting the other things. There is long phrase, the noun, or the long phrase, the noun, that verb, or long phrase may produce long phrase, and noun may produce this one, verb may produce this one, in this way. And this is maybe 1500 rules, and you will have a reasonable grammar of English, like these things. You just see. That means what I mean to say, that means production rules is a very much important for generating the grammars as well as the forming the sentence of the English, sentence of the language, any language, whatever may be these things. Now, next things what we will see, basically we are coming to the next phase, that is syntax analysis phase, or known as the parsing. We have seen what the compiler do. That is, a compiler is a program that reads a program written in one language known as the source language and translate it into another language, that is the target language. Compiler operates in phases. We have seen already: source program, lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, code generator, and finally maybe the target code generator. Now, what is parsing? That is parsing or the syntax analyzer. You just see, parsing is the process of determining whether a string of tokens can be generated by a grammar. Process of determining whether a string of tokens can be generated by a grammar. And most of the parsing techniques fall into one of the two classes. One is known as the top-down parsing, another one is the bottom-up parsing. We have already seen the concept of the top-down and bottom-up. What is that? Now, in the top-down parsing, construction starts at the root and proceeds to the leaves. That means starting from our start symbol, we will reach to our final sentences. Whereas then the bottom-up parsing, construction starts at the leaves and proceeds towards stop. That is, starting from the sentences, we will start to reach to our start symbol. Efficient top-down parser are easy to build by hand, but bottom-up parsing, however, can handle a larger class of grammars, and they are not easy to build, but there are some tools generating them directly from the grammar. This is, we have seen that two types of defined types of grammars. Now, What may be the different types of grammar? We just see, we'll see in details. Top-down parsing. Top-down parsing may be predictive parsers, maybe one of the top-down parsers. LL1 grammars or LL1 parser may be another type of parsers. We will see details of the top-down parsing. We will see like that. That is, just see. Here. Besides this, we will see that is parsing can be divided into two categories. One is the top-down one we have seen and the bottom-up one. Top-down parsing, again I am telling you, starting from the start symbol, we will try to reach to our final strings or the sentences. And that means, what is the definition? Again, you just see when the parser starts from constructing the parse tree from the start symbol and then tries to transform the start symbol into the input, known as the top-down parsing. There may be two types of the top-down parsing. Basically, the approaches may be used in the top-down parsing, maybe which we have seen. Just predictive parser, we will see LL1 or maybe LLK grammar. Different types of grammars are there in case of top-down parsings. And that is, you just see there are two techniques has been used in the top-down parsing. This is not the classification. This is the techniques used in the top-down parsing. One is the recursive descent parsing. Another one is the backtracking. I'm not talking about the category. The way the top-down parsing is worked is the recursive descent one. Another one with the help of the backtracking. Recursive descent means it's a common form of the top-down parsing. It is called recursive as it uses some recursive procedures to process the input, but it suffers from the backtracking. And what is backtracking? We know that means if one derivation of a production fails, the syntax analyzer starts the process using the defined rules of the same production. And this technique may process the input string more than once to determine the right production. You just see one example here where backtracking is required. Just see. You just see. This is your two production rules are given. S produces CAD and capital A produces AB or A. This is, you know, capital A's and capital. That means in the grammar, capital symbol means it is the non-terminal symbols. And small means it's the terminal symbols. And null means it's the leap symbols also. Now, in order to find the derivation for W produces CAD, what should be your parse tree? If you start from these production rules, S produces CAD, now you just see capital A produces AB. That means you can use these things. And here, what are you getting? CABD. This string you may get. But this is not your requirement. That means what you have to do? You have to backtrack. And in that case, again, you have to restart from the upper level. And in that case, now you will use A produces A and you are getting CAD. This is the things. Are you understanding why backtracking is required here? Okay. Now, first we will see the details of the bottom-up parsing. Then we will come back to the top-down parsing. And after bottom-up parsing is over, then we will come to the top-down parsing again. You just see here another example of the bottom-up parsing. Bottom-up parsing starts from the input symbols and tries to construct the parse tree up to the start symbol, as I have told you. This is your input string. A plus B starts C, and these are the production rules. S produces E produces E plus T, E produces E star T, E produces T, and T produces ID. And finally, we'll try to reach from starting from this string, input string, we'll try to reach in S. You just see. This is the way we are reaching to S. A plus B starts C. Now, A, B, and C is the ID. That is, instead of A, we are writing in the T. That means right hand side production will be replaced by the left hand side. That means T. Now, E produces T. That means T will be replaced by E. That is, we are getting these things. Now, B should be replaced by T. And E plus T. You just see. Next, we are getting E plus T start C. You just see E produces E plus T. That is, E plus T will be replaced by E. Now start C, and C is there. C is replaced by T. Now E start C will be replaced by E, because there is a production. E produces E start T, and now another production, S produces E. Finally, we are reaching to this start symbol. Is it okay, this example?
Yes, sir.
It's not difficult one. Okay. Now, let us start the bottom-up parsing. Already we have seen the concept of the parsing techniques, that is top-down parser, maybe the LL1, recursive descent, like these things, and bottom-up parser, maybe LR1 or operator precedence. We will see the top-down parsing later on. First, we will start from the bottom-up parser. That means start at the leaves and grow towards the root, and we can think of the process as reducing the input string to the start symbol. This is known as the reduce parser. And here top-down parser means produce. Start from the start symbol, it produces the input strings. That is, this is known, top-down parser is known as the producing techniques. Here from the start symbol, you will try to reach to your start symbol. In the bottom-up parser, what you are doing, from the input string, you will try to reach to your start symbol. That is why it is known as the reduce. You can think of the process of reducing the input string to the start symbol. At each reduction step, a particular substring matching the right-hand side of the production is replaced by the symbol on the left-hand side of the productions. And the bottom-up parsers handles a large class of grammars. Again, I am repeating these things. Bottom-up parser handles a large class of grammars, and top-down parser means it is producing, and bottom-up parser means reducing. That is why the basic idea of the bottom-up parsing, the approaches, maybe one of the popular approaches, the shift reduce parser. Bottom-up parsing works in this manner. Shift reduce parsing. Because it has two main actions, shift and reduce. We will see with an example. At each shift action, the current symbol in the input string is pushed onto a stack, and at each reduction step, the symbols on the top of the stack, that is the symbol sequence, is the right hand side of the production, will be replaced by the non-terminal on the left hand side of the production rules. There are two more actions will be there, that is accept and error. Shift, reduce, accept, and error. Just a minute. Isa, I have send in your WhatsApp a picture. You just share it to others.
Yes, sir.
Yeah. You just see. I think everybody has got that picture.
Yes.
You just see in the picture. There are three components. One is the input string. Another block is there, that is shift reduce parser, and another one is the stack. What you will see, that means for each shift action, as the shift reduce parsing, at each shift action, the current symbol in the input string is pushed to the stack. And at each reduction step, the symbol on the top of the stack, and what is that? That symbol sequence is the right side of the production, will be replaced by the non-terminal at the left side of the production. And there may be two more actions are there, that is accept, that is announce the successful completion of the parsing, announce the successful completion of the parsing, and error means it will give some signal, that is discovery of some syntax error. Let us see an example. You will see. Have you got the picture? Has everybody? Everybody have got the picture?
Yes, sir.
Yeah. Okay. Just see the steps compared with the picture. That is, input string is there. You need to, current symbol in the input string is pushed to the stack. And at each reduction step, this is basically shift action. And each reduction step, the symbols on the top of the stack will be replaced by the non-terminal at the left-hand side of the production. Besides this, there are two more actions. One is the accept, another one is the error. That means accept means it will announce successful completion of the parsing, and error means what is that? Signal discovery of the error. That means it will give some signal for the discovery of the syntax error. Now let's see next one. That is what I've told you. A shift reduce parser tries to reduce the given input string into a start symbol. At each reduction step, a substring of the input matching to the right side of the production rules and is replaced by the non-terminal at the left side of the production rules. If the substring is chosen correctly, the rightmost derivation of that strings is created in the reverse order. We'll see these things. Nothing is there. Rightmost derivation. See these things. If this is your production, the way we have seen one example, let me show you another example. Shift reduce parser, that is, it reduces string to the start symbol of the grammar. At every step, a particular substring is matched in the left to right fashion to the right side of the same production, and then it is substituted by the non-terminal on the left side of the production. You just see, this is your production rules, and this is the string needs to be passed. What are you doing? You just see A, B, B, C, D, E. Now you just see here, A produces A, B, C or B. Here you just take B. B is your, B may be reduced with capital A. Now you just see next one, A, B, C. A, B, C will be reduced by capital A. That is, you are reaching these things. Now D will be reduced by B. That is A, B, E. You are getting. And now this is your, that means A, B may be reduced by S. This is your, just reduce these things, and the way rightmost derivation, that means from the start symbol you are reaching these things. We'll just use the follow reverse step in order to reach to a start symbol on this string. Example is clear?
Yes, sir.
Now, very much important, this terminology handles. What is the handle of a string? Substring that matches the right hand side of some production and whose reduction to the non-terminal on the left hand side is a step along the reverse of the some rightmost derivations. That is, a handle is a right sentential form. That is, a production rules A produces beta and is in a position of gamma. That is, where the string beta may be found and replaced by A to produce the previous right sentential form in the rightmost derivation of the gamma. You just see here. Here what do you do? A, B, B, C, D, E. B has been reduced by capital A. That means you just see first one, A produces B. This is the handle in that case. That means B has been reduced by A. Now A, B, C. A, B, C has been reduced by A. That is, after this, A produces A, B, C is the handle. Now, what you have got? D produces by B. That means B produces D is the handle here. And now A, B, E has been reduced by S. That is, S produces A, B, E. This is the handle here. This way, we are getting these things. That means if your rightmost derivation is like these things, alpha A omega or W produces alpha B W, in that case alpha beta W, in that case A produces beta may be reduced by A, that is, from this side from right to left, what are you getting? This one, alpha A W, and in that case A produces beta is the handle of the alpha beta gamma at the location immediately after the end of alpha. And if the grammar is the unambiguous one, that is, every right sentential form of the grammar has exactly one handle. If the grammar is the right sentence, unambiguous grammar. That means every step, only a single step will be used for the reducing these things. Let us see an example. You just see in this example. What we have seen, again, what I have told you, this is the things. ACE produces, here actually we are showing in the right hand way, that means producing these things. ACE produces A, B, then this one, and this one, we are getting these things. That is, ACE produces A, B, E is a handle of A, B, E in location 1. This has been, now D is the handle of A, D, E in the location 3. That means you just see B has been replaced by B will replace by D. This is location 3. Now A produces ABC is a handle of these things. ABC, that is location 2. That is starting ABC, where A is there at the position 2. And now A produces B. What is it is that A hasn't produced these things, that is location 2. Just see. Is it okay? This is basically what I have shown you for your understanding, but the way handle we will use, we will try to reduce these things. Reduce these things. From right to left, we will reach there. And handle pruning means a rightmost derivation is reverse can be obtained by handle pruning. You just see. Here actually this is the production rules is given, and as per the strings, if we replace the handles with the corresponding non-terminals, and this is basically you are getting, finally you reach these things and replace each of the handles with the help of the corresponding non-terminals. This is basically known as the handle pruning. And if you are not getting that proper handle, that means unable to identify the handle, in that case you may not reach to your terminal. That means you reach to your start symbol, and in that case you may be get blocked. You just see A, B, B, C, D, E. Here actually B has been replaced by capital A that we are getting. Now B is in location 3. Now B is in the location 2 is a handle, but B is in the location 3. Now it is not a handle, because again if you replace this B by A, what you are reading? You are reaching here, and you won't be able to do further reduction. That is why this is the block. That means you have to identify here B at location 2 is the handle that needs to be, that can be reduced by the non-terminals, but B at location 3 is not a pure handle. Clear? Are you getting these things?
Sir, can you repeat these things?
Hello? I'm not
Can you
getting
repeat?
it properly.
Can you please repeat these things? Like why this is not a handle?
You just see. You have understand what is handle? Is it clear what is handle? Who is asking me? You just answer me whether it is clear. This slide is clear.
Yes, sir.
Yes. Then you just see here. This is the same production rules we are using, and this is the string which needs to be parsed. That means from this string we may try to reach our start symbol, that is S. Now you just see there is a production rules where capital A produces small b. Okay. Now that means if you take B in both ways, you can take this B as your handle, you can take this B as your handle. If you take this B as your handle, this is okay. It's like a B at location 2. That means whatever you're reaching, A, B, C, A, B, C. Now that A, B, C, this may be another handle, and that can be reduced by capital A. But instead of doing these things, if you again take B at location 3 as the handle, what are you getting? That means B will be reduced by capital A. Now what is the string you are getting here? small a followed by 2 capital A, then CD. Now, which handle you will use to reduce to your source terminal, or that is your start symbol? Is there any possibilities there?
No, if this is the case, there will be no possibilities after A, C, D, E.
Yeah, that means you have been blocked there. That means you cannot use B at location 3 as a handle. Although you are substituting B, small b by the capital A, but after reaching these things, you won't be able to move further. And that is why small b at location 3 is not the handle at all.
Understand.
Okay. That means what is handle pruning again? The process of discovering a handle and reducing it to the appropriate left-hand side is called the handle pruning. And handle pruning forms the basis of the bottom-up parsing. Same way it is written. Just let me explain with an example. You just see here how the shift reduce parser works. This is the input string ID plus ID star ID, and this is your production rules. We just see the rightmost derivations of ID plus ID star ID. That means from the starting symbol, how we are reaching to these strings, that is ID plus ID star ID. E produces E plus T, and T produces T star F. Now F produces ID, that is E plus F star ID. Now F produces ID, that is we are reaching these things, and E produces T, T produces F, and finally F produces ID. That means we are reaching here. Now, this is the rightmost derivation for ID plus ID star ID. Now, we have just, for the shift reducing one, we will just do the reverse one. That means starting from this, we'll try to reach E here. You just see ID plus ID star ID. Now, ID is your handle. That means F produces ID is your handle. We have that, in that case, that ID is your basically start symbol, basically current input symbol, and that will be reduced by this is, that means ID will be shifted to the stack. Now ID will be reduced by F. Next, and F will be reduced by T. Now next, your next ID current input symbol after plus current input symbol is ID, that will be reduced by F, and F will be reduced by T with the help of these production rules. And next, this ID will be your current input symbol, that will be reduced by F, and T star F, that will be reduced by T, that is E plus T, and E plus T will be reduced by E. And this is the basically handles are the red and underlined in the right sentential form. This way the shift reduce parser works. Is this clear? Just tell me whether
Yes,
it is.
sir. Yes, sir. Clear.
Do you have any class after my class?
Yes, sir.
Class is there?
Yes, sir.
Yes or no? Class is there or not?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir, there is class.
Okay. Okay, you just see next one, the stack implementation of the shift reduce parser. That is, we have already discussed these things. There are 4 possible actions of a shift reduce parser. One is the shift, that is the next input symbol is shifted on the top of the stack. Now reduce, replace the handle of the top of the stack by the non-terminal. Next one is the accept, that is upon successful completion of parsing. And error means parser discovers a syntax error and calls an error recovery routine. An initial stack just contains only the end of the marker, end of the string marker, dollar, and the end of the string may be marked by the end of the string marker, dollar, which we'll discussed. Just see with the help of the algorithms. Okay. Okay. As we have class right now, I'm stopping right now, and I'll discuss this in the next day. Okay.
Okay.
Okay, sir.
Thank you, sir.
Isa, you
Yes,
just
sir.
try to find out another time, so that this time is very bad time. I don't want to take the class now. In that case, I may take the class today from 9 a.m. or like these things. Okay, from the next week.
আচ্ছা, ঠিক আছে স্যার।
আমি দেখে আমি বলে দেবো তোকে।
আচ্ছা আচ্ছা স্যার, আমি এখন আপনাকে কল করবো?
এখন বা ক্লাসটা হয়ে যাক না, তুই বিকালের দিকে কল করিস, তাতে অসুবিধা নেই।
আচ্ছা ঠিক আছে, ওকে স্যার।
ওকে।
मुन्ना, है मुन्ना। मुन्ना बोले तो दूसरा मुन्ना बोल रहा है। क्या बजे यार, तुम क्लास में क्या क्या भेजते हो यार? क्या भैया? क्या लगता है 16-17 लोग हैं और लास्ट में हम बात करते हैं तो क्लास खत्म ही हो गया होगा।